Okay, today I'll go through revision form 2 chapter 9 speed and acceleration. Okay, the first part, for you to remember what is speed. Rate involving distance and time. When they say rate, it involves, what is it? You must know. It involves what? You can straight over draw this to understand it deeply. So what is it? This is D, this is S, and this is T, where D is the distance, S is the speed, and T is the time. Okay, so you have to remember this, huh? So it's quite easy actually. For you, from here you can get many formulas. To find S, you close the S, okay, with your finger. So the formula is D divided by T. Then if you want to find T, you close the T with your finger, and you'll get D divided by S. And then if you want to find D, you close the D with your finger, then D is equals to S times with T. So if you know this, then everything else is easy for you. Okay, this is the main formula you need to know to do questions involving speed and acceleration. Okay, so now I'll go through. Okay, what is uniform speed? What is uniform speed? Is when, example, a bicycle, okay, it moves at same speed in every part of the journey. Okay, it moves at the same speed in every part of the journey. That is the meaning of uniform speed. Okay, so which means in the graph, I'll just sketch the graph. In the graph, okay, all these are the uniform speed. Okay, this is the uniform speed, where this is the distance in meter and this is the time in second. Okay, so the next part, what is non-uniform speed? Okay, when it moves at different speeds in every part of a journey. So remember this, huh? So what is What is uniform speed? It is the moves at the same speed in every part of the journey. So what is non-uniform speed? It moves at a different speeds. This is speeds in every part of a journey. So same goes for the graph. I'll just sketch. Is it different speeds in every part of the journey? So like this. Change the color. All these are the speed at different point, you see. Okay, where the same thing, this is the distance in meter and this is the time in second. Okay, so make sure you understand what is the meaning of it, uniform speed and non-uniform speed. So next, what is average speed? The formula is total distance traveled divided by total time taken. Okay, I'll go through one example, just one example. I'll write the example over here. Okay, I'll write a bit small. Encik Ali drives 75 km from Penang to Ipoh. The journey takes 1 hour 15 minutes. Calculate the average speed in kilometer per hour of his car. So always remember, students, always remember, this is very important. In kilometer per hour, sometimes they'll be asking in different units. Okay, so be careful with it. So how you do this? Encik Ali drives 75 km from Penang to Ipoh. The journey takes 1 hour 15 minutes. Calculate the average speed. You just use this formula. Am I right? So you just use that formula. And the formula is total distance traveled. What is the total distance traveled by him? 75 km. So average speed is equals to 75 km. And then I divide it by, I don't have to change the kilometer because they're asking in kilometer per hour. Okay, so I have to divide by the total time taken. What is the total time taken? 1 hour 15 minutes. But the time they're asking in hours, so which means you have to change the minute to hours. How you change that? You all should know how to do this, but still I'll show. 1 hour plus 15, I divide by 60 minutes, where I get the hour. So I'll be getting 1.25 hour. Okay, so I'll put here 1.25 hour. So once you press your calculator, you divide, you're gonna get the answer 60 km per hour. This is the average speed. Encik Hali has moved. This is your answer. Okay, that is the one example, and this is the easiest example. Okay, this is not something hard. This is the easiest example. So next, okay, next it's actually about acceleration. Okay, acceleration. So what is acceleration? Rate of involving speed and time. Okay, so from here we'll get a formula. So acceleration is equals to change of speed divided by time taken. Okay, so acceleration is equals to change of speed divided by time taken, and from here you'll get another formula. Final speed minus initial speed divided by time taken. Okay, so we'll get this and also this. So change of speed is same as final speed minus the initial speed and divided by time taken, which is the same lah. Okay, so I'll give you a small note here. Okay, when a vehicle accelerate, the speed increases and when the speed of a vehicle decreases, the vehicle experience negative acceleration. Okay, which is called as deceleration. Okay, so small note for you to understand what is deceleration, what is when the speed decreases, what happens, speed increases, what happens. A small note for you. Okay, okay, so next, yeah, okay, I'll give you a small example about the formula that I've given you just now. Okay, okay, so I'll just tell to you the question. Listen carefully. The diagram shows a particle accelerates from stationary. I'll draw for you. Okay, a diagram shows a particle. Okay, a particle. Okay, a particle accelerates from stationary. When they say stationary means from not moving, okay, and reaches the speed of 50 meter per second. Accelerate, okay, to 50 meter per second in 4 seconds. In 4 seconds. Calculate the acceleration. They're asking, calculate the acceleration in meter per second square of the particle. As I said once again, this is very important. That is the unit of acceleration actually. Okay, so how you do this? You just follow the formula. Change of speed over time taken. What is change of speed? Final speed minus initial speed. Over here, what is the final speed? The final speed is 50 meter per second minus the initial speed is 0 meter per second, and I divide it by time taken. What is the time taken? 4 seconds. So here I'll be getting 50 divided by 4, where the answer will be 12.5 meter per second square. This is your answer. This is the easiest question that you can understand. Okay, there's some more harder. Okay, so the next part, is about conversion. I'm pretty sure that you all know how to convert a particular unit, but still I'll go through it. Okay, I'll go through it. So listen. Conversion of units. Okay, conversion of units. 1 kilometer is equals to 1000. Because I know some students still don't know this. 1 meter is equals to 100 centimeter. Okay, 1 hour is equals to 60 minutes, which equals to 3600 seconds. Okay, and 1 minute is equals to 60 seconds. Okay, this is basic, and this is like a flashback. Okay, this is like a flashback. Okay, so for the units of speed that are usually used, okay, is kilometer per hour or kilometer per hour also, but it is negative. You bring up the hour. Okay, then the second one is m per minute or m minute negative 1. Then meter per second or meter second negative 1. You bring everything up, that's all. Okay. Okay, how about conversion of for acceleration? This is for speed. This is for speed. Okay, so you must know this is for speed. Conversion of units for speed. Okay, so now I'll go through the conversion of acceleration. Okay, which unit you'll be using usually. Okay, so this is conversion of units for acceleration. Okay, so they usually use kilometer per hour square or kilometer hour -2, and then they use meter per second square or meter per second -2. The last one is m per minute square or m minute -2. So this is the conversion of units they use for acceleration. Okay, so make sure you take note. Okay, so that's all for today. I've done chapter 9 form 2 speed and acceleration. Okay, hope you guys understand it. Thank you.